So 49, we have two objects connected over a pulley. M1 is sitting on the table. M2 is hanging off the pulley. We're given M1. M1 is equal to 10 kilograms, so we'll just put that here. 10 kilograms, and M2 is 5 kilograms. And we're told the system starts from rest. M2 falls 1 meter in 1.2 seconds. Determine the coefficient of kinetic friction between M1 and the table. So what we're trying to find up here, there's friction between block 1 and the table. What is the coefficient of kinetic friction? Right there. Now, let's start with this. See this sentence right here? M2 falls 1 meter in 1.2 seconds, starting from rest. What can we do with this info right here?
Find velocity.
Well, we could find the final velocity, but there's something better than the final velocity. I'll give you a hint. What's this chapter all about? F net equals ma. We can find the acceleration from that information right there. How do we get the acceleration from that info? With a kinematic. So you got to go back to chapter 2 here and just apply a kinematic to this information. So M2 starts from rest. It falls a distance of 1 meter in a time of 1.2 seconds. V initial is 0. Okay, so the kinematic that's going to solve this, x equals 1/2 at squared plus v initial t. There is no initial velocity, so a is 2x over t squared. So this is going to be 2 times 1 meter over 1.2 seconds. Hey, squared. I'm leaving this 1 meter right here. I'm leaving it positive because remember, for pulleys, what do we say? Like, which way is M1 going to accelerate?
Positive.
M1 is going to accelerate to the right, so what are we going to say? Let's say that to the right is plus, to the left is minus. So that's the sign convention up here for M1. Well, what happens to this sign convention here? It goes around the pulley. So for M2, what are we going to say? Down is plus, up is minus. The sign convention wraps the pulley. So anyway, this acceleration, it's going to be a positive acceleration. It comes out as 1.38 repeating meter per second squared. So now we have the acceleration. We're going to need that. Okay, so how do we go about solving the problem, which is finding the coefficient of friction between M1 and the table? What do we have to do to find the coefficient of friction? Step 1, free body diagram. You always start with your free body diagrams. So let's do that. So we got the acceleration, 1.38. So now let's do our free body diagrams. So I'm going to erase the ropes here. Not to say the ropes are not there, but it'll just help with the free body diagrams. So take the ropes off. We know that's M1. We know that's M2. All right, so here, we'll put it here. So this is 10 kilograms. So M1, 10 kilograms. And then here is M2, 5 kilograms. All right, what are the forces that are on M1? In the x direction, what's pulling block 1 to the right? Tension. What's acting to the left? Friction. That's mu times normal force. Hey guys, is that a kinetic friction or a static friction? Is it kinetic or static?
Oh, static.
It's kinetic. How do I know it's kinetic?
That's kinetic.
The block's moving. If it's moving, it's kinetic. If it's not moving, it's static. The way you deal with kinetic friction and the way you deal with static friction, it's the same approach. Same exact approach. Okay, in the vertical direction, what force is pushing down on block 1? mg. But don't just say mg. You got to say what? m1g. Okay, what's acting up on the block? Fn, the normal force. Okay, that's our sign convention for M1. That's our free body diagram for M1. Okay, now let's look at M2. What are the forces on M2? What's acting up on M2? Tension. What's down? M2G. Okay, let's put in sign conventions here. Let's be real clear so we don't make any mistakes. So I'm going to do the sign convention in red. Okay, what's going to be the sign convention for M1? Let's say to the right is plus, to the left is minus, right? Now, what's that sign convention going to do around the pulley? It goes around the pulley, so what do we get down here? Down plus, up minus. Does that make sense? Okay. And then what about the vertical up here for M1? For the vertical, you know, down minus, up plus. So there's the full sign convention for M1. And then this whole thing wraps around the pulley. Down plus, up minus, like that. Okay, any questions up to this point? So you got to kind of set everything up so you can see the forces. If you can't see the forces, you're not going to get the question correct. All right, so now for M1, what are we going to do? Oh, and I guess I should add one other thing here. What's the acceleration of both of these masses? We already calculated it. 1.38. That's our acceleration for both masses. Okay, for M1, let's sum forces X. Let's sum forces Y. And then for M2, sum the forces. You don't have to call it X or Y because there's only one direction, you know. All right, for the X direction, what forces are on M1 this way? There's only two. Tension and friction. So you're going to go T minus mu Fn. Mu Fn is friction. Any other X forces on M1? Nope. So what does the sum of the forces equal?
M1A.
M1A. Does the A go to 0? No, because we have an acceleration. All right, in the Y direction for M1, we have normal force up and M1G down equals M1A in the Y. So that acceleration is X. Okay, is block 1 accelerating this way?
No.
No. There's no acceleration in the Y, so we can cross the Y acceleration to 0. Just replace this with 0, because there is no Y acceleration. Okay, now let's look at M2. Remember, for M2, down is plus. Okay, so we're going to go M2G minus T equals M2A. All right, the hard part is now done. The remainder of this problem is algebra. Okay, so I'm going to make some room. We don't need this anymore. I'm going to scoot this up. Okay, so solving this, what are we trying to solve for here? The thing we're trying to solve for is what? Mu. We're trying to get mu. All right, so what I would do is go like this. We're going to need the normal force. What's the normal force going to equal? Normal force is equal to M1G, where M is 10 kilograms. Gravity's 9.8. It's a homework problem, so I'm using 9.8. So 98 newtons. The normal force is equal to 98. Okay, now take this equation, solve it for T. T equals M1A plus mu Fn. Take this equation, solve it for T. T equals M2G minus M2A. What do we know about the T's?
Equal.
They're equal. What do we know about the A's? They're equal. So look, what we're going to do, so if the T's are equal, that means that this and this are equal. So let's set those equal. So we're going to get M1A plus mu Fn equals m2g minus m2a. And now let's solve for mu. Mu is going to be m2g minus m2a minus m1a all over normal force. So look, I'm out of room here, but when you plug the numbers in, it'll come out as 0.29. Mu comes out as 0.29. Okay, and remember, we have our A. We calculated, how did we get that acceleration? Where did we get the acceleration from? We calculated it from what? A kinematic. So now you can plug the A in.